April 4, 1943, Kure Naval Arsenal, Japan. Professor Hiroshi Tamura stood at the edge of the laboratory table, his fingers tracing the edge of the steel fragment recovered from an American destroyer. The morning light filtered through the high windows, casting long shadows across the pristine white laboratory floor. Outside, cherry blossoms drifted on the spring breeze, a stark contrast to the tension that hung in the room. The metallurgist was confident that he would soon uncover the secret weakness in American steel that would turn the tide of the naval conflict in the Pacific. "American manufacturing is efficient but sloppy," Tamura remarked to his assistant Kenji Nakamura. "We will find their weakness, and when we do, our submarines will know exactly where to strike their vessels." Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the story of how a team of brilliant Japanese scientists set out to exploit a perceived vulnerability in American warships, only to discover a humbling truth that would change their understanding not just of metallurgy, but of the industrial might they were facing across the Pacific. Professor Tamura had been handpicked for this critical assignment. At 47 years old, he was considered the foremost metallurgical expert in the Imperial Japanese Navy. His credentials were impeccable: a doctorate from Tokyo Imperial University, 5 years of study in Germany before the war, and 17 published papers on maritime steel alloys. The Naval Ministry had provided him with everything he requested: a dedicated laboratory at the Kure Arsenal, 6 skilled assistants, and most importantly, access to rare specimens of American steel salvaged from damaged ships. "The Americans produce ships like toys on an assembly line," Lieutenant Commander Yoshiro Fujioka said as he delivered the latest samples. Fujioka, the naval intelligence officer assigned to the project, placed a heavy wooden crate on the laboratory floor. 7 days to build a Liberty ship. 7 days. They sacrifice quality for speed. Find the flaw, Professor. Tamura nodded solemnly. Quality cannot be rushed. Our craftsmen spend months ensuring each steel plate meets the Emperor's standards. The Americans have chosen quantity over quality, and that will be their downfall. The samples had been collected at great risk. Some were recovered by submarine crews from damaged American vessels that had limped away from battles. Others came from sunken ships raised from shallow waters. Each piece told part of a story, and Tamura was determined to read that story in full. Kenji Nakamura, Tamura's chief assistant, was only 26 years old, but already showing remarkable promise in metallurgical analysis. "Professor, I have compiled the preliminary data from the tensile strength tests," he said, presenting a neatly handwritten report. "The American steel is surprisingly consistent across different vessels. The variation is minimal." "Consistency is not the same as quality," Tamura replied, taking the report. "Begin the microscopic crystalline structure analysis. I want to see how their steel behaves under extreme stress conditions." The laboratory became their home for the next several weeks. The team worked tirelessly, often sleeping on cots in the adjacent room. They subjected the American steel samples to every test imaginable: repeated stress cycles, extreme temperature fluctuations, saltwater corrosion acceleration, and detailed metallographic examinations of the grain structure. Captain Toshio Miyazaki from the Naval Construction Division visited frequently, eager for results. "The Americans launched 98 new ships last month alone," he informed Tamura during one such visit in early May. "Our entire yearly production is being outpaced by their monthly output. We need a strategic advantage, Professor. We need to know where to target our limited torpedoes for maximum effect." Tamura remained confident. "Every manufacturing system has its weaknesses, Captain. Mass production especially. We will find it." As the research progressed, however, something unexpected began to emerge from the data. Nakamura was the first to notice. "Professor, look at these microstructure photographs," he said one evening, laying out several images on the light table. "The grain boundaries are remarkably consistent. I expected to find significant variations due to their rapid production methods, but—" Tamura peered at the images, a slight furrow appearing on his brow. "Run the tests again, different samples this time." They did, with the same results. The American steel was not just adequate, it was excellent. The crystalline structure revealed a material that had been precisely formulated and carefully processed. There were variations, certainly, but they fell well within acceptable parameters, sometimes exceeding Japanese naval standards. "This cannot be correct," Tamura muttered, rechecking the calculations himself. "Their production speeds should make this level of quality impossible." Lieutenant Hideo Takahashi, the team's materials engineer, suggested a different approach. "Perhaps we should examine their welding techniques instead of the base material. Mass production welding is notoriously problematic." This new line of inquiry led them to study the junction points where steel plates were connected. They obtained several welded sections from various American vessels and subjected them to rigorous testing. Commander Fujioka visited again in late May, his expression tense. "The Naval Ministry requires an update, Professor. What have you found?" Tamura hesitated before responding. "We have eliminated several possibilities. The base steel composition is, surprisingly good. We are now examining the welding techniques and junction integrity." "But you have found weaknesses?" Fujioka pressed. "We continue to search for them," Tamura replied carefully. After Fujioka departed, Nakamura approached Tamura with a concerned expression. "Professor, I believe we should discuss what we're actually discovering." Tamura nodded slowly. "Yes. Let us be honest among ourselves, at least." That evening, the research team gathered in the small conference room adjacent to the laboratory. The walls were lined with charts, photographs, and test results accumulated over weeks of intensive study. "The facts are becoming clear," Tamura began, addressing his 5 colleagues. "The American steel is of excellent quality. Their welds are consistent and strong. Despite their rapid production methods, they are achieving results that equal, and in some cases exceed, our own standards." The room fell silent as the implication of his words sank in. "But how is this possible?" asked Assistant Engineer Masato Tanaka. "Their shipyards employ untrained civilians, women and elderly men with minimal experience. How can they produce such quality?" Tamura had been pondering this question for days. "I believe we have fundamentally misunderstood the American approach to manufacturing." He walked to the chalkboard and began to sketch. "Traditional shipbuilding, as we practice it, relies on highly skilled craftsmen performing specialized tasks sequentially. The quality depends on individual expertise developed over many years." Next to this, he drew another diagram. "The Americans have developed something different. They have standardized every component and simplified every task. They have created templates and guides that allow less skilled workers to achieve consistent results. They have engineered the process itself to prevent errors, rather than relying on skilled workers to avoid them." "So their system compensates for individual inexperience?" Nakamura asked. "Exactly, and more importantly, they have developed quality control procedures that test materials at every stage. They catch and correct errors before they become problems." The team spent hours discussing these revelations, examining their data in this new light. What they were discovering wasn't just about metallurgy. It was about 2 fundamentally different approaches to industrial production. The next day, they received an unexpected visit from Admiral Takeo Kurita, commander of the Second Fleet. The presence of such a high-ranking officer sent the research team into a flurry of activity, straightening the laboratory and organizing their findings. Admiral Kurita was direct. "Professor Tamura, I understand your research is taking longer than anticipated. The Naval Ministry is growing impatient." Tamura bowed respectfully. "Admiral, our investigation has taken us in unexpected directions. We have been thorough in our analysis." "And what have you found? Where are the American weaknesses?" Tamura exchanged glances with Nakamura before responding. "Admiral, with respect, we have discovered that the presumed weaknesses do not exist as we expected." The Admiral's expression hardened. "Explain." Over the next hour, Tamura presented their findings, supporting each conclusion with meticulously gathered data. He explained how American steel production had been refined for mass manufacturing while maintaining high quality, how their welding techniques had been standardized for consistency, and how their quality control procedures caught defects early. "So, you are telling me," Admiral Kurita said slowly, "that their ships are well built despite their rapid production?" "Yes, Admiral. In fact, They are well built because of their production methods, not despite them. The Admiral paced the laboratory, hands clasped behind his back. This is not what the Naval Ministry wants to hear, Professor. I understand, Admiral, but it is what our research has revealed. After the Admiral departed, the atmosphere in the laboratory remained tense. Everyone understood the implications of their findings, not just for their research project, but potentially for the course of the naval conflict. Will they listen to us? Nakamura asked quietly. Tamura sighed. I do not know, but we will continue our work. There is more to understand here. The team refocused their efforts on a broader analysis of American manufacturing techniques, studying not just the materials, but the production processes that created them. They obtained documentation from naval intelligence, technical manuals, training guides, even American industrial magazines that had been collected before the war. What emerged was a picture of an industrial revolution unlike anything they had anticipated. The Americans had developed a system that Captain Miyazaki had once dismissively called assembly line shipbuilding, but which now appeared to be a masterstroke of industrial engineering. In June, Professor Tamura was summoned to Naval headquarters in Tokyo. He traveled by train, carrying with him a comprehensive report of their findings. The journey gave him time to reflect on the implications of what they had discovered. The meeting at headquarters included several high-ranking naval officers and representatives from the Ministry of Munitions. Tamura presented his team's findings methodically, explaining how the American approach to mass production had achieved both quantity and quality. The Americans have completely redesigned the shipbuilding process, he explained. They have broken down complex tasks into simpler components that can be standardized and repeated. They use templates, jigs, and guides to ensure consistency. And critically, they have implemented statistical quality control methods developed before the war. Admiral Suemu Toyoda, the newly appointed chief of the Naval General Staff, listened carefully. You are suggesting that their industrial methodology is superior to ours? In terms of combining quality with quantity, yes, Admiral, Tamura replied, knowing the dangerous territory he was entering. Their Liberty ship program is producing vessels in days rather than months, yet those vessels are proving remarkably resilient in combat conditions. The room grew quiet. Criticizing Japanese methods, even implicitly, was professionally risky. Vice Admiral Takejiro Onishi spoke up. Professor, are you familiar with the production figures for our new aircraft carriers? Only generally, Admiral. We will complete perhaps 2 fleet carriers this year. The Americans launched 7 in April alone. If what you are saying is correct, then we face not just a numerical disadvantage, but a qualitative one as well. The implications hung in the air. Japan's strategy had always assumed that superior Japanese quality and fighting spirit would overcome American numerical advantages. If that assumption was false, the strategic calculations of the entire war effort would need to be reconsidered. What do you recommend, Professor? Admiral Toyoda asked finally. Tamura had anticipated this question. We must study and adapt their methods to our own production. We must reorganize our shipyards and steel mills to incorporate their quality control procedures and standardization techniques. It will require a significant adjustment, but that would take years we do not have, interrupted Rear Admiral Chiaki Matsuda from the Naval Construction Command. And it would require us to admit that our methods are inferior, unacceptable. The debate continued for hours, growing increasingly heated. By the end, it was clear that while some officers recognized the significance of Tamura's findings, others were unwilling to accept their implications. The meeting concluded without a clear resolution. On the train back to Kure, Tamura felt the weight of responsibility bearing down on him. His team had uncovered information that could potentially influence the direction of the naval war, yet institutional resistance might prevent that knowledge from being properly utilized. Upon his return, he gathered his team. Our findings have been received with mixed reactions, he told them. We will continue our research, focusing now on how we might adapt some American methods to improve our own production without sacrificing our traditional strengths. Nakamura seemed troubled. But, Professor, will they actually implement any changes based on our work? Some will try. Others will resist. Our job is to provide the clearest possible picture of reality, regardless of whether it matches expectations. In July, their laboratory received an unexpected visitor, Dr. Shizuo Fujita, a renowned physicist from the Naval Research Division. He arrived without prior notice, apparently on a personal initiative rather than an official assignment. "Professor Tamura," he said after introductions had been made, "I have read your report on American steel production. Your findings align with what I have observed in other areas of their military manufacturing." Over lunch in Tamura's modest office, Fujita shared his own research into American aircraft production. "They are applying the same principles to airplane manufacturing that you've identified in shipbuilding: standardization, simplification, statistical quality control. But there's something more fundamental at work here." "What do you mean?" Tamura asked. "The Americans have a different philosophical approach to industrial production than we do. We value the skill of the craftsman, the attention to detail, the pursuit of perfection. They value process engineering, systems thinking, and consistent outcomes." Tamura considered this. "Yes, that aligns with our observations." "But here is what troubles me," Fujita continued, lowering his voice. "Our military leadership doesn't fully comprehend what this means. American production isn't just about numbers. It's about creating a system that continuously improves itself. Their factories learn and evolve at a pace we cannot match under our current paradigm." The conversation with Fujita gave Tamura new perspectives to explore. Over the following weeks, his team expanded their research to examine not just the physical properties of American naval steel, but the entire production ecosystem that created it. They studied American management techniques, training methods, and quality control systems. They analyzed how feedback from naval battles was incorporated into design improvements. They examined how the Americans coordinated between mines, steel mills, shipyards, and naval operations to create an integrated production chain. In August, they produced a comprehensive report titled "Analysis of American Naval Industrial Methods and Their Applications to Imperial Production." The document detailed not just their metallurgical findings, but offered specific recommendations for how Japanese naval production could adapt certain American techniques while maintaining traditional Japanese craftsmanship where it offered advantages. The report was submitted to Naval Headquarters. Weeks passed with no official response. Then, in early September, Tamura received a classified communication ordering him to significantly revise the report, removing sections that suggested Japanese methods might be inferior and focusing instead on potential weaknesses in American vessels that could be exploited tactically. "They want us to tell them what they wish to hear, not what they need to know," Tamura told Nakamura after receiving these instructions. "What will you do, Professor?" Tamura was silent for a long moment. "I will comply with the letter of their instructions while preserving the substance of our findings. The revised report will appear to give them what they want, but anyone who reads it carefully will understand the true implications." The team worked on the revised report, carefully wording their findings to emphasize objective facts while avoiding direct comparisons that might offend naval leadership. The new document highlighted areas where American production might potentially create vulnerabilities: junction points between prefabricated sections, standardized components that might fail under specific conditions, while subtly indicating that these theoretical weaknesses were generally addressed by American quality control systems. In late September, Captain Miyazaki visited again. After reviewing their progress, he took Tamura aside. "Professor, I must speak frankly," he said in a low voice. "Your original report is circulated among certain forward-thinking officers. Not officially, of course, but copies have been shared. There is a growing faction that believes we must adapt our industrial approach along the lines you suggest." Tamura was surprised. "I had assumed our findings were being suppressed. Officially, yes. Unofficially, your work has sparked intense debate. Admiral Yamamoto himself requested a copy before we lost him." The mention of the Commander-in-Chief of the Combined Fleet, who had been lost earlier that year, gave Tamura pause. If Yamamoto had seen value in their research, perhaps all was not lost. "There is more," Miyazaki continued. "The Mitsubishi shipyard in Nagasaki has begun quietly implementing some of your recommendations. They've reorganized their welding processes using templates and guides similar to those used in American yards. Early results show a 30% increase in production speed with no reduction in quality. This news gave Tamura a renewed sense of purpose. Even if official channels were resistant, their work might still make a difference through unofficial adoption. As autumn arrived, the research team shifted focus to examining the organizational structure of American shipyards. They analyzed how the Americans managed their workforce, particularly the integration of previously untrained civilians into complex manufacturing processes. Their training systems are remarkably efficient, Nakamura noted during one analysis session. They use what they call training within industry programs, simplified job instructions, standardized methods, visual guides. A worker with no prior experience can become productive within days rather than months. Tamura was particularly interested in how American shipyards employed women in roles traditionally held by men. They're not just replacing male workers, he observed. They're redesigning jobs to match the available workforce. When they discovered that women often have better fine motor control, they assigned them to precision welding tasks. The result was actually improved quality. In October, the team received new samples from a different source: American merchant vessels that had been damaged by submarine attacks. These Liberty ships, built even faster than naval vessels, provided additional insights into American mass production techniques. "Look at this welding pattern," Nakamura pointed out during their examination. "It's done by someone with minimal training, but the template they've used ensures the weld is placed exactly where needed. The quality isn't exceptional, but it's consistently adequate. Consistently adequate at scale is more valuable than occasionally perfect in limited quantities," Tamura replied, a perspective that would have seemed heretical to him months earlier. As they continued their research, news from the Pacific grew increasingly grim. American industrial might was making itself felt across all fronts. New ships, aircraft, and weapons were appearing in quantities that Japan could not match. In November, Tamura was again summoned to Tokyo, this time to present directly to a select committee of industrial planners from both the Navy and the Army. This meeting had a different tone from the previous one, less defensive, more pragmatic. "We need to understand exactly how the Americans have achieved their production miracle," stated Lieutenant General Heisuke Yanagawa from the Army's Industrial Planning Board. "Professor Tamura, your team has done the most comprehensive analysis of their methods. We need practical recommendations that can be implemented immediately." Tamura laid out their findings systematically, focusing on concrete steps that could be taken to improve Japanese production efficiency. He explained how American shipyards had standardized components, created foolproof assembly guides, implemented statistical quality control, and reorganized workflows to maximize output. Their system is built on the principle that the process must compensate for variations in worker skill, he explained. They design tasks so they can only be done correctly, with physical guides and templates preventing errors. The response was more receptive than at his previous presentation. Questions focused on practical implementation rather than defending traditional methods. Plans were made to send industrial engineers to observe the Mitsubishi yard in Nagasaki, where Tamura's recommendations were already being tested. Upon returning to Kure, Tamura found his laboratory had been expanded. Additional engineers had been assigned to his team, and they had been given access to more resources. Their mission had been officially broadened to include developing specific recommendations for Japanese shipyards based on their analysis of American methods. "Things are changing," he told his original team. "Slowly, perhaps too slowly, but they are changing." In December, they completed a comprehensive training manual for shipyard workers based on American training within industry concepts, but adapted for Japanese cultural contexts. The manual included simplified job instructions, quality check procedures, and visual guides that could help inexperienced workers perform complex tasks consistently. Several shipyards began implementing these new methods. Production speeds increased, though not dramatically. Cultural resistance and existing infrastructure limited how quickly changes could be made. As 1943 drew to a close, Tamura reflected on the journey his team had undertaken. What had begun as a search for weaknesses in American naval steel had evolved into something much more profound, an examination of two contrasting industrial philosophies and their implications for modern warfare. In January 1944, Tamura was reassigned. The official order stated he would be heading a new Industrial Methods Research Division tasked with studying and adapting efficient production techniques across multiple naval manufacturing facilities. Nakamura would accompany him as his chief assistant. Before departing Kure, Tamura visited the laboratory one last time. The room where they had begun by searching for flaws in American steel now housed a broader effort to understand and adapt American production methods. Charts comparing traditional craftsmanship with mass production techniques lined the walls. Training manuals for shipyard workers filled the bookshelves. A model of an American-style assembly line occupied the central table. Lieutenant Commander Fujioka, who had initially tasked them with finding weaknesses to exploit, visited to bid farewell. "You found something different than what we expected," Fujioka said. "Yes," Tamura agreed. "We sought vulnerability and found strength. But in understanding that strength, perhaps we have made ourselves stronger as well." "Perhaps," Fujioka replied, though his expression suggested doubt. "Though I fear we have learned these lessons too late." Tamura could not disagree. The industrial gap between Japan and the United States was widening, not narrowing. American factories were now producing ships, aircraft, and weapons at a pace that seemed almost mythical. For every Japanese vessel lost, the Americans seemed to launch 10 more. Before departing for his new assignment, Tamura met privately with Nakamura in his office. "We will continue our work in the new division," Tamura said, "but I want you to understand something important." "Yes, Professor. The lessons we have learned go beyond metallurgy or manufacturing techniques. The Americans have developed not just better methods, but a different way of thinking about production. They see it as a system, with each component, human, mechanical, organizational, working together." Nakamura nodded. "I've been thinking about this as well. Their approach seems less traditional, less refined, but the results are undeniable. Yes, and there is something more fundamental at work. Their system succeeds partly because it is open to change. They gather data, analyze problems, implement solutions, and then begin the cycle again. Their factories learn and evolve." Tamura paused, choosing his next words carefully. "Whatever happens in this conflict, this approach to industrial organization will shape the future. Japan must understand and adapt to it, or we will be left behind in the post-war world." "You believe there will be a post-war world for Japan?" Nakamura asked quietly. "I do. And we must be prepared to help rebuild our nation with these new methods when that time comes." As they prepared to depart for their new assignment, news arrived of another American innovation, a new class of escort carriers being produced at the astonishing rate of 1 vessel every week. These ships, while smaller than fleet carriers, were being deployed in numbers that made them a significant force in the Pacific. "How can they build aircraft carriers in weeks?" asked a young naval officer who had brought the intelligence report. "It should be impossible." Tamura exchanged glances with Nakamura before responding. "It would be impossible using traditional methods, but they have reinvented the process itself." In their new division, Tamura and his team worked to spread the knowledge they had gained. They conducted training sessions for industrial engineers, prepared detailed reports for shipyard managers, and developed simplified guidance for workshop supervisors. Progress was made, but never quickly enough to change the trajectory of the conflict. Japanese production improved incrementally, while American production continued to accelerate exponentially. By mid-1944, the strategic situation had deteriorated further. American forces were advancing across the Pacific, supported by an ever-growing fleet of vessels that seemed to appear as if by magic. The industrial might that Tamura's team had analyzed was now making itself felt in every theater of operations. In June, Tamura received an unexpected invitation to meet with Matsutaro Shoriki, the influential publisher of the Yomiuri Shimbun newspaper, and an advisor to the government on industrial policy. They met at Shoriki's private residence in Tokyo, away from official channels. "Professor Tamura," Shoriki began after pleasantries had been exchanged, "I have read your reports on American manufacturing methods with great interest. Your analysis goes beyond military applications. Yes, these principles could be applied to any industrial context," Tamura agreed. "Precisely. And that is why I wanted to speak with you privately." Shoriki lowered his voice. "There are those of us who are thinking about Japan's future beyond the current conflict. When peace eventually comes, our nation will need to rebuild. The methods you have studied could be essential to that rebuilding." The implication was clear. Some influential figures were already looking beyond the war, anticipating defeat and planning for reconstruction. It was a perspective that could not be openly discussed in official circles. "I believe you are right," Tamura replied carefully. "These industrial methods will shape the post-war world, regardless of which nations adopt them." "I want you to prepare a comprehensive document," Shoriki said, "not for current military application, but for future implementation. A blueprint for adapting these methods to peaceful Japanese industry. Can you do this discreetly, alongside your official duties?" Tamura agreed. Over the following months, while continuing his official work, he and Nakamura secretly compiled what would later be called the Reconstruction Industrial Framework, a detailed plan for implementing American-style mass production techniques in Japanese civilian industries after the war. As 1944 progressed, Tamura watched as the fruits of American industrial might continued to overwhelm Japanese forces across the Pacific. Ships that his team had studied on paper were now dominating the seas in reality, their steel hulls proving just as resilient as his metallurgical analysis had suggested. In November, Tamura's division received one final ironic assignment: to analyze a new American naval vessel that had been damaged in the Philippines. The ship was one of the mass-produced destroyer escorts that were now being completed in less than 6 months from keel laying to commissioning. "Examine the construction techniques and materials," the order stated. "Determine if their rapid production has finally led to quality compromises that can be exploited." When the salvaged steel plates arrived at their laboratory, Tamura and Nakamura conducted the analysis personally. The results were unsurprising to them, though they would still disappoint Naval Command. The quality was excellent, the welds consistent, the material properties within optimal parameters. "Their system continues to improve," Nakamura observed as they reviewed the test results. "These welds are better than the ones we examined a year ago." "Yes," Tamura agreed. "While we have been struggling to implement basic changes, they have continued to refine their methods. Each generation of ships incorporates lessons from the previous one." This final analysis would prove to be their last significant contribution to the war effort. As American forces drew closer to the Japanese home islands, resources for research diminished. By early 1945, Tamura's division was operating with minimal staff and equipment. In April 1945, with American forces now on Okinawa, Tamura received a visit from Shoriki's representative. They met briefly in a small tea house in Kura. "Shoriki-san wants you to know that your document has been secured," the man said quietly. "Copies have been placed in multiple locations. When the time comes, it will be retrieved and used." Tamura nodded. "Thank you for letting me know." He also suggests that you and Nakamura-san consider relocating away from major industrial centers in the coming months. The warning was clear. Tamura and Nakamura arranged transfers to a small research facility in the countryside of Hiroshima Prefecture, away from the major cities and naval bases that were now being regularly targeted. As the war drew to its inevitable conclusion, Tamura reflected on the journey that had begun with that fragment of American steel in his laboratory. What had started as a search for weakness had instead revealed strength, not just in the steel itself, but in the system that produced it. When the conflict finally ended in August 1945, Tamura and Nakamura were among the technical experts quickly recruited by the occupation authorities to assist with reconstruction planning. Their knowledge of American industrial methods made them valuable intermediaries between occupation officials and Japanese industrial leaders. In 1946, Shoriki retrieved the document they had prepared and presented it to the newly formed Ministry of Commerce and Industry. Many of its recommendations would be implemented in the following years as Japan began its remarkable post-war industrial transformation. Tamura would later serve as a consultant to Toyota Motor Corporation, helping to implement and then improve upon American production techniques. The Toyota production system that emerged would eventually surpass its American inspirations, creating a new global standard for manufacturing excellence that combined the best of mass production efficiency with traditional Japanese attention to quality. In 1960, nearly 2 decades after he had first examined that piece of American naval steel, Tamura gave a lecture to industrial engineering students at Tokyo University. Now 74 years old, he reflected on the lessons of that wartime research. "We set out to find a weakness in American steel," he told the students. "Instead, we discovered the future of industrial production. The materials themselves were important, yes, but more important was the system that created them. A system that valued process design, standardization, and continuous improvement. The American ships never broke apart, not because their steel was magical, but because their entire approach to manufacturing was revolutionary. They had created a system where quality was built into the process rather than inspected into the product. In our defeat, we learned something valuable, something that has helped Japan rise again as an industrial power. Sometimes, the greatest discoveries come when you are looking for something else entirely." The students listened attentively, taking notes on the insights from a man who had witnessed firsthand the industrial transformation that had reshaped the global order. Few of them realized that many of the manufacturing techniques they were now studying, techniques that were making Made in Japan a global mark of quality, had their origins in that wartime metallurgy laboratory in Kure. As Japan entered its high-growth period, the principles that Tamura had documented would help transform the nation into an economic powerhouse. The steel analysis that had begun as a military project had ultimately contributed to a peaceful revolution in industrial methods, one that would eventually see Japanese manufacturing quality surpass even that of the Americans whose techniques they had studied. The full circle was completed in the 1980s, when American manufacturers began studying Japanese methods to improve their own operations. The lessons had now flowed in both directions across the Pacific, a quiet victory for the professor who had once sought weaknesses and instead found strength. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.